Right now, somewhere on the coast of Thailand, there are elephants doing ordinary things. They eat. They dust themselves. They follow the same trails they've followed for decades. But on December 26, 2004, something happened that nobody who witnessed it could fully explain. Hours before one of the deadliest tsunamis in recorded history made landfall, before any human sensor had registered it, the elephants started screaming. They broke their chains. They ran inland toward high ground, and they didn't stop until the water came. The tourists who followed them survived. The ones who stayed on the beach are among the 230,000 people who didn't come home that day. The question isn't whether that happened. It did. The question, the one that should genuinely unsettle you, is, did the elephants know? Not did they feel a tremor, but did something behind those eyes understand what the tremor meant and decide to run? The answer isn't what the science expected, and it has nothing to do with instinct. There's a difference between reacting and knowing. You're knee-jerks when a doctor taps it. You're not deciding to do that. The question with the elephants isn't whether their bodies responded to something. It's whether there was a mind behind the response. Whether, behind those eyes, something thought, we need to move. And the first person to take that question seriously wasn't a biologist. It was a man reading the lost pet section of the newspaper. In the 1970s, a geologist named Jim Birkeland noticed something strange in the classified ads of local newspapers. In the weeks before major earthquakes, lost pet listings spiked significantly. He used it to predict the 1989 Loma Prieta earthquake, the one that stopped the World Series and collapsed a section of the Bay Bridge. Partly on the basis of missing animal reports across the Bay Area, the U.S. Geological Survey called his methods unscientific. His work was never formally validated, but the animals kept doing it anyway. The classified ads turned out to be the least strange part of what researchers would eventually find. Because before you can ask whether an animal knows, you have to understand what it can feel. And on that, we are almost embarrassingly outmatched. Animals sense things we can't, not because they're psychic, but because they're built differently. Elephants perceive the world partly through infrasound, low-frequency vibrations far below the threshold of human hearing, around 14 to 35 hertz. Seismic activity generates exactly these frequencies, sometimes hundreds of miles from the epicenter, hours before the surface event. And elephants don't just hear this through their ears. They detect ground vibrations through the fatty pads in their feet. They are, in a very literal sense, listening to the earth in a way we physically cannot. Sharks detect changes in barometric pressure through the ampullae of Lorenzini, gel-filled canals that register electrical signals at a sensitivity of 1/1000th of a volt per centimeter. Before Hurricane Charlie hit Florida in 2004, tagged blacktip and nurse sharks moved into deeper water days in advance. The pressure changes were too subtle for any human to perceive. The sharks felt them directly. Dogs can hear frequencies up to 65,000 hertz, 4 times our upper limit, with a sense of smell up to 100,000 times more sensitive than ours. These animals are not living in our world. They're living in a richer, louder version of the same world, flooded with signals we stopped being able to hear. But the senses only explain the warning. They don't explain what the matriarch did next, and for a while, the science said there was nothing to explain at all. In 2008, the U.S. Geological Survey published the results of the most rigorous animal earthquake prediction study ever attempted. Researchers monitored over 200 animals across 3 active fault zones for 2 years. Their conclusion was unambiguous. No statistically significant predictive behavior was detected. None. The lead researcher told the press the idea was a myth that the data does not support. That should have been the end of it. Except that 10 years later, a team in Germany wasn't looking for earthquake prediction at all, and found it anyway. In 2018, a study published in Scientific Reports attached GPS trackers and accelerometers to farm animals on a rural property in Germany. They were studying herd movement patterns. The But 6 hours before a magnitude 4.0 earthquake struck the region, every animal showed a coordinated, statistically significant change in behavior. The cows moved into the center of their field and stopped. The sheep grouped tightly. The dogs began moving in tight circles near the farmhouse. Then the earthquake hit. They scattered. The behavior change began earlier, the closer the animals were to the epicenter, consistent with detecting something propagating outward from a central point, something the instruments didn't register until the moment of the quake itself. But sensing a tremor is one thing, yet what happened in Zimbabwe wasn't sensing at all. It was memory. In 2004, researchers documented a herd of elephants in Hwanje National Park moving in an unusual direction, away from their established dry season range, 3 days before a severe drought caused a critical water source to fail completely. The younger elephants had never experienced a failure at that waterhole. The waterhole showed no visible signs of stress when the herd departed. But the matriarch had been there before. She was in her mid-50s. She had lived through a severe drought in the same region in the late 1960s, 40 years earlier. Researchers could not explain the movement by any present-day sensory signal. The most plausible explanation, she had retrieved a specific memory from 40 years earlier and acted on it. She hadn't sensed the disaster coming. She had remembered the last one. There's a concept in animal cognition research called episodic-like memory, the ability to recall not just that something happened, but when and where, and use it to make decisions in the present. The gold standard evidence comes from an unlikely subject, the western scrub jay. Researchers Nicola Clayton and Anthony Dickinson at Cambridge showed that jays remember what food they cached, where and when, retrieving perishable items before they spoil, non-perishable ones later. That's a timeline. That's a mental model of the past being used to make decisions in the present. If elephants have episodic-like memory, and the behavioral evidence increasingly suggests they do, then what moved through that matriarch's mind wasn't instinct firing blindly. It was something closer to recognition. The ground felt like this. The air felt like this. And then the water disappeared. One matriarch could be a coincidence, but this has happened at the scale of entire cities. In 2011, a magnitude 9.0 earthquake struck the Tohoku coast of Japan. In the hours before the shaking began, animal behavior at facilities across the region shifted. Flamingos grouped tightly. A panda began pacing. King cobras, snakes that can remain motionless for days, began moving restlessly. Different species, different sensory systems, all registering something on roughly the same timeline. This wasn't new. After the 1976 Tangshan earthquake, which killed an estimated 240,000 people, investigators compiled hundreds of accounts of unusual animal behavior in the hours before. Snakes emerging from hibernation in winter, horses refusing to enter their stalls. The Chinese government actively researched whether animals could serve as a formal early warning system. They successfully predicted the 1975 Haicheng earthquake and evacuated the city hours before a magnitude 7.3 quake leveled much of it, saving an estimated 150,000 lives. 1 year later, Tangshan struck without warning. The animals knew there too. Nobody was listening that time. So they sense it. Some of them remember it. But there's one question all of this runs into, and science still can't get past it. All of this is behavioral. We can observe what animals do. We can never get inside what they feel. The philosopher Thomas Nagel made the problem permanent in 1974. We will never know what it's like to be a bat or an elephant. We can study every neuron. We can never get inside the experience. And yet, in 2012, neuroscientists at the Francis Crick Memorial Conference at Cambridge signed the Cambridge Declaration on Consciousness, concluding that the structures generating conscious experience in humans are not unique to humans. Mammals and birds possess the same neural substrates. The hardware that runs awareness in your brain exists in theirs too. Franz de Waal went further. He argued we should be shocked if animals didn't have inner lives. Consciousness almost certainly evolved gradually, the same way eyes evolved, across millions of years. Which means it exists on a spectrum. And we are not at one end with everything else at the other. The animals that fled before the 2004 tsunami didn't write a report, they just moved. We built seismographs, we built ocean buoys and satellite networks. And on the morning of December 26, 2004, the most accurate early warning system on that coastline had 4 legs, felt the ground through its feet, and was already running. The Huanji matriarch led her herd to water across unfamiliar ground. Without her, they would have followed habit to a waterhole that had run dry. She had remembered something across 40 years. She had acted on it. The herd had followed. That's not instinct. Instinct doesn't have a timestamp. Instinct doesn't say, last time this happened, here is what worked. Whatever moved through that elephant's mind, whatever it feels like, if it feels like anything at all, it looked, from the outside, an awful lot like wisdom. The kind that takes a lifetime to earn. The kind we tend to assume is ours alone. So the question isn't whether they know a disaster is coming. The question, the one we keep not asking loudly enough, is what else they know, and how long they've been trying to tell us.